Good morning, everyone, and welcome to our Database Cloud Service Office Hours. We really appreciate you joining us today, and we have a really exciting topic, and we have a very distinguished list of speakers and panelists with us today. My name is Tammy Bednar. I'm a product manager in the database team, focusing on the database and database cloud services. So this is June 11th, June 11th, 2020, our office hours is going to focus on the Sharding Oracle Database Cloud Service. That's really exciting. Sharding, I know we've been talking about Sharding for quite a few years, and it's really exciting that now we're going to offer this to you as a cloud service to really help with your applications that are looking for this type of distributed and scalability capabilities. So our speakers today are Shailesh, and he's our VP of Product Management under Sharding. We have Bharath, who is our developer of Sharding. We have Param, who is a member of our Rack Pack. And then we have panelist Mark Dillman. He's our development manager for Sharding and Global Data Services, and Sanjay Singh, who's the senior director of the Rack Pack. So as you can see, we have a lot of heavy hitters and a very distinguished list of speakers today to bring you all this great information. So with that, I'll turn it over to Shailesh and kick us off.
Thanks, Tammy, for the introduction. I hope you guys can see my screen.
Yes.
Thank you. So thanks everyone for joining. Today we will be talking about database sharding. And from an agenda point of view, we'll take a quick look at sharding. I think most of you probably are familiar with sharding, and that's probably the reason you are here today. And then we'll look at how we can enable sharding on Oracle Database Cloud Service in Oracle Cloud. And if there is a little more time left at the end, then we'll talk about some of the new features we have introduced, which are there in 19 and 20C version of Oracle Database. So what is sharding? Sharding basically is one of the approaches which has been taken by a lot of big internet scale companies for providing horizontal scalability as the workload increases. So it's basically horizontal partitioning of data across independent databases, which we in Oracle database sharding terminology refer to as shard. And each of the shard holds a subset of data. And it's basically a shared nothing architecture, which means it does not require any specialized hardware or software for it to work. So in this picture on the right side, what I'm showing is that just for the sake of discussion, we have a single database. It has a single table, say table 1, and the table has say rows, say 300 rows. So what we do is with sharding is that we take row number 1 to 100, say we put it on on shard number 1, which is nothing but a regular Oracle database instance running on a specific node, which is a server 1. We took row number 101 to 200, and we can put it on shard number 2, which is database instance running on server 2, and row numbers say 201 to 300, we can put it on shard number 3, which is running on regular database instance running on server 3. So it's basically, as I said before, horizontal partitioning of data across independent Oracle databases, which we call a shard. And this does not require any specific, it's, as I said, it's a shared nothing architecture, so we don't need any special software for clustering or NAS or a SAN storage or network cards, and none of that is needed. And additionally, what we also do is that for clients accessing the application from an application side, we connect those clients directly to the node where the data is residing. So we have automation and capabilities built into our drivers so that the application gets connected directly to the node where the data is sitting. So that way, with the minimum or no change to applications, they can basically use the sharded architecture for their scale out needs. Now, the benefits of sharding are, number 1 is linear scalability. That means if you have more transaction volume, more data size, then what we can keep adding these shards, and that the architecture itself lends into this nice linear scalability. The second big benefit why customers use sharding is extreme availability, where if one of the nodes goes down, we have high availability and failover and all that. We'll talk about it in a second. But if there is a small blip or a brownout, during that small blip or brownout, only a subset of data is not available. So in my previous example, if shard number 2 went down, only say if you're sharding by customer ID, then customer 101 to 200, they will experience any kind of blip during that period, while other customers and other nodes will be healthy and continue to provide services. The third big benefit is global databases or geographic data distribution. Many of our customers are global, applications are global, and there are a lot of data jurisdiction and data residency requirement which mandate that say European data stays in continent of Europe, US, North America or US data stays in US, Japanese data stays in Japan, so on and so forth. So with sharding, we can have these shards, which are independent Oracle database instances residing in these different geographies in different locations. But from an application point of view and from an operational point of view, still a single logical database. So global data distribution is yet another big use case which we see customers adopting sharding for. As I said before, it's a shared nothing architecture. So the shards can all be on premises. Some of the shards can be on premises, some can be in cloud, and all of them could be cloud, which is what we are going to talk about today and show you a demo how we can leverage sharding in Oracle Cloud with Oracle Database Cloud Service. The key customer use cases we are seeing is a variety of that. We just put a few of them on the slide. And so these are the use cases which customers told us what they're using sharding for, Oracle Database Sharding for. These are the competing products they looked into. And then at the bottom of the slide, I try to capture the reasons which customers said why they used Oracle instead of some other vendors. And this slide is based on real customer who are using the product and the feedback we got so far. So internet scale online transaction processing. So things like mobile to mobile payment applications or point of sale application where data latency is critical, data consistency is critical. We can't have best effort or eventual consistency in that model. So that's a class of customers where customers did consider other competing products like many NoSQL products which claim to give scalability like Cassandra, Mongo, MemSQL, MariaDB, so on and so forth. And eventually went with Oracle as the applications needed complex joins, strict data consistency, security, multi-region replications, triggers, stored procedures, security patches, manageability, scale, all the great things which you are familiar with Oracle database. That's pretty much the operational and the runtime capabilities of the product is why they chose Oracle. Another use case is global databases where customers like say Citigroup, Citibank, who were a co-presenter with that at last Open World, they have an application which has over 100 terabyte of data spread across the globe in multi-regions. And they basically are looking at sharding to be able to support a true global database where data is residing in different geographies, honoring data residency. Log store is another interesting use case we are seeing where with Oracle databases, converged database capabilities where we can not only store structured data, but unstructured data like text and JSON in the same data store, and we can shard it. And all of a sudden you see that that is exactly what likes of Lucene or Elasticsearch or Solar, etc., other log analytic products and vendors support this. So we are seeing customers who are actually using Oracle databases, text store capabilities and JSON capabilities and try to shard it to achieve similar use case so that they have one core data store to manage, monitor, and run. Metric data, time series data, like where you have Internet of Things like application, monitoring application, infrastructure monitoring of where the data is coming at a very high speed in small clips where or global DNS services. So we have many customers in that space who have evaluated these other products and using Oracle database sharding. Machine learning is also a very interesting use case where we can not only shard the database in the data tier, but also in Oracle database we support machine learning algorithm inside database. So we can leverage the compute horsepower of the sharded data stores to run AI and ML right where the data is stored. And then big data analytics is another set of use cases where things like Apache Spark, MemSQL, where we have all the shards where we can actually fan out queries in parallel on all the shards and run them. So that gives us the similar capabilities around this space. So what we offer with Oracle Database Sharding is the best of both, which is the capabilities of a mature RDBMS, which provides data consistency, complex joins, trigger stored procedures, SQL, all of that good stuff which you're familiar with Oracle database, plus the scalability and manageability like the NoSQL database. Here is a proof point from Forrester, and they acknowledge Oracle databases, converged database capabilities, where the same data store engine can be used for things like OLTP, IoT, microservices, multi-model, data science, AI, ML. So this is a quote from Gartner, and I have posted a link as well from them. And as I said, with Sharding, we are basically providing similar capabilities with a lot of point solutions out there. Here's a ranking from Gartner, where Gartner ranked Oracle database on the top. And specifically, if you look at the sharding capability, which they talk about under distributed variable data use case, where geographic distributed geographic distribution of data, as well as the automation in terms of partitioning of data, they ranked Oracle as #1. Interestingly, they called out deficiencies in Amazon's offering in this space, and Google Cloud Spanner is listed at the very bottom. So this is the part we are talking about today, specifically around distributed data variable. So let's take a quick look into how sharding works under the hood, and then we'll get into a demo on how sharding can be used in Oracle Cloud. So here's what we are showing is that that there is in sharding we have a concept of a table family, and this is how we basically partition the data. So in a given table family, in this picture I'm showing that we have a customer, order, and line item. Let's assume there are these three tables, and we have like Mary, John, and Peter as the three rows here. So what we do is, for sharding purposes, we take all of the Mary's customer information, order, and line item and put it on shard #1, which is running, say, on database instance 1 on server 1. John's information goes on shard 2, and Peter's information goes on shard 3. And that way, when we run a query to say, show me all orders for Mary, that query gets satisfied on shard 1. So our goal is to ensure that that a query or the join gets satisfied on a local instance, and we don't have these nodes talk to each other at the runtime. Otherwise, that will not give us the nice scalability we talked about, right? And same when Peter's or John's data is residing here, and those joins are satisfied locally. We also have a notion of something we call as a duplicate table, and typically this is the reference data which you need on all of the shards to be available to satisfy joins. So for a good example is a product catalog, which does not change that often and is not that voluminous. So what we do is, for this type of data, we keep a copy of this data on all of the shards. So now if I want to run a query saying, show me all products which Mary bought, that query still gets satisfied locally on this host. And at the runtime, these nodes don't even talk to each other. So that way, we get the nice linear scalability. We also support multi-shard queries, which we call through some a component called multi-shard query coordinator. And these you can think of as analogous to, say, MapReduce kind of functionality, Hadoop MapReduce, where what we do is, when the query comes in, we fan out that query in parallel to all the shards. Each of the shard executes that query on the subset of data they have, and the results are returned back to the client. So that way we can leverage the parallelism across all these compute instances running sharded Oracle database. Under the hood, we pack data in something we call as a chunk, and it's important to understand because this is our unit of data movement. So in a chunk, we store basically the partitions for a given table family. So this is what a shard looks like, that you have different chunks, a chunk 1 to chunk 120. In chunk #1, we have customer 1 to 1 million, their order and line item. Chunk 120 has customer 5 million to 6 million, their order and line items. And then we have the duplicate table data. All of these shards are highly available. So we protect them using active data guard if you are looking at shared nothing architecture or Golden Gate, or the shards can also run on a rack if you choose to. And some of our big reference customers, biggest bank in Russia or China Telecom, one of the biggest telecom provider in China, they are running each of the shard is a 2-node rack architect deployment. Or many of our customers are just like Epsilon, etc., are just running shards protected with the data guard as well. From a kind point of view, I said that sharding all our different drivers like JDBC, OCI, Universal Collection Pool, ODP.NET, all the different flavors of drivers, they are sharding aware. They are topology. They understand the data distribution topology, and when the client request comes in, we connect the client directly to the node where the data resides. And I already touched upon multi-shard query coordinator capabilities, where we do allow queries which span all the shards. For example, select count star from customer. We optimize that query and push it in parallel on all the shards, and each of the shards run that query on the subset of data they have and send it back. And some of the sharding methods, basically how we can partition data. So we allow by consistent hash, which is system managed sharding and user defined. And then third is composite sharding, which nobody else in the industry has it other than Oracle. So system managed is leveraging consistent hash. If you have say 10 shards, and the point being spread my data uniformly across all 10 shards. If I add 11th shard, spread all my data uniformly across all 11 shards. I don't want to micromanage data placement. So I let system do the placement of data, right? So that's system managed. User defined, if you are familiar with the data partitioning, then it's the same as range and list, where you can say customer 1 to 100 goes on shard 1, 101 to 200 goes on shard 2. So you have full control on ranges. Or list, where you can say if a customer's state of residence is somewhere, say on East Coast of United States, like Florida, New York, put them in a East Coast data center, or if it's a West Coast like California or Oregon, put them on a West Coast data center. So that's like a list example, you can do that. Or composite, as I said, is very unique to Oracle, where we allow two level of sharding, where you can use two different approaches, where you can say if basically range plus consistent hash or list plus consistent. And this is what enables our global database use case, where we can say if a customer's country of residence is somewhere in Europe, for example, Germany, or Belgium, put them in a data center in Frankfurt. And within Frankfurt, I have say these 3 shards, a pool of 3 shards, spread data uniformly. Or we can say if customer's country of residence is somewhere in North America, like United States, Mexico, Canada, put them in a Phoenix data center, and I have 5 shards there. So I don't want to do the micro management of data placement in Phoenix, spread them uniformly using consistent. So basically it's a 2 level of sharding scheme, sharding method, sharding keys, which we can use to support this use case. Lifecycle management of sharding. So once you have set up your shards and you add a new shard, then we have the ability to move the data, rebalance your data. We talked about the chunks, and that's our unit of data movement. So you can add an empty shard, and then you can move, you can rebalance all your shards. So now that's the data is spread uniformly across the shards. We have ability to break these chunks into 2. If one of the chunks is getting hot by either by the volume of data or the queries, then we can break it into 2 and move one of the parts of the chunk to another shard. You can grow the cluster, you can shrink the deployment. That's exactly what Epsilon is using sharding for. They were, co-speaker at Open World 2019. There we have all the recording and material from them as well. But basically, due to address the seasonality aspects, where they want to add more capacity during say holiday season and then shrink it back, allows that kind of use case. Monitoring and management. So you can use your familiar tool in Oracle Cloud. We have the OCI console, which has a lot of metrics for database cloud service. We can use that. If you're running on premises or even in OCI and using Enterprise Manager Cloud Control, we have deep manageability and monitoring capabilities built into that. Patching, upgrade, other lifecycle management, we just use the regular tooling. Each of this shard is nothing but a regular Oracle database. We have another component called Sharding Advisor. If you are starting from a non-sharded Oracle database and you want to shard it, you can run this tool. It will give you recommendations by looking at the real usage of your database instance in terms of how to shard and what to use for a sharding key. So with that, let's take a look at some of the options available in Oracle Database Cloud Service, how we can use sharding there. One of the ways is we can use sharding with the Database Cloud Service instances. Bharat is going to do a demo of that. Another option we have is we can use sharding with the Kubernetes and Docker containers available in Oracle Cloud through OKE. And then we have also published some customer-inspired reference architectures, to which you can look at if you want to see how other customers are doing things and how you want to deploy sharding in workflow. So with that, Bharat, you can take over the control. And
sure. Thanks, Shailesh. Good morning, all. I'm Bharat Amprasad, a principal software engineer with Oracle on the Shard database team. Right? So for the next few minutes, I'm going to be talking about Oracle Database Sharding on OCI Marketplace. So with that introduction, let us look into why you may want to use sharding on OCI and deploy and manage on OCI Marketplace, right? So first, it is utterly simple and intuitive and easy to use Oracle Shard database on OCI from OCI Marketplace, as it just takes a few clicks to get up and running with a production scale Oracle Shard database, all within a matter of few minutes. Second, it is really easy to manage Oracle Shard database with just a single click, be it scaling in or scaling out. So lastly, it is very easy to navigate and access all Shard database resources once it is deployed. So now let us take a look at an example of Shard database topology on OCI. So as Shailesh was discussing, the main components of Shard database shown here are Shard director, Shard catalog, and the shards. So a typical deployment topology would have one or more Shard directors responsible for request routing, right? So basically the Shard directors are responsible for request routing coming in from the clients, and a Shard catalog and its standby in different ADs are responsible for cross-shard queries. And also a request coming in from the Shard director. So the Shard director quickly looks up the metadata store in Shard catalog to look up the key information and map the key to the shard on which the user data resides and routes it to the appropriate shard, right? So and the other component which you see is the shards. And it's the primary shards and its corresponding standbys, again, deployed across availability domains that are responsible for showing customer data, right? So here we are using, as you can see, between the primary shards and the standby shards, we're using DataGuard as a replication technology. And when the request comes in, the shard director routes the request to the appropriate shard, given the sharding, with a quick lookup, as I said earlier, right? So now, if the request is a read-write workload, it is routed to the primary shard group. And if the request is a read-only workload, it is routed to the standby shard group, as you can see here. Okay, moving on. So with that basic understanding, right, of what a Oracle Shard database topology looks like on OCI, let's take a look at the salient features of Oracle Shard database on OCI Marketplace. So first, it supports system managed sharding on Oracle Extreme Performance Database Edition. Second, it also does automatic and uniform distribution of shards, catalog, and shard directors across ADs in a region and fault domains within each AD. It also supports DataGuard based data replication, which you just saw in the example topology for shards and catalog, and thus provides high availability within a region. It also provides the ability to easily scale the number of shards and thus providing horizontal scalability. It also provides the ability to easily scale the number of shard directors for high availability and load balancing of requests. Okay, now let us take a look at an OCI Marketplace-based sample Oracle Shard database deployment architecture. So within the user-chosen Oracle Cloud region, we create all the network fabric required for Shard database deployment, including VCN, a regional subnet, security list, routing table, as well as an internet gateway within the customer tenancy. Right? So as you can see, each layer of components here, right, be it Shard director layer or catalog layer or the shard layer, is basically spread across. So you can see that it's spread across automatically uniformly across different ADs within a region, and also across fault domains within each AD. So each layer here is independently scalable, be it the shard director layer or the shard layer, right? So In this particular sample deployment architecture, you can see that the user has chosen 2 shard directors to be deployed, and then a catalog to be deployed, as well as 6 primary shards to be deployed. And he has set the replication factor to 2, wherein each layer catalog, as well as the shard layer, has its own set of standbys. So for each primary shard, there is a standby shard automatically provisioned. Okay. So with that, let us get straight to the live demo of Oracle Shardabase on OCI Marketplace. Okay, so as you can see, this is the listing of Oracle Database Sharding on OCI Marketplace. You can see over here that we have the documents, a quick introduction here, and then some documentation about how to use it on OCI Marketplace and how to manage it as well. So without further ado, let me go ahead and launch this particular stack, right? So the compartment which I'm choosing is a sharding demo. You can choose whatever compartment you want to provision shard database in. Let me click on launch stack. Now, this is the stack information which we're going to put, which is the shard database stack, which we just clicked on launch for. So now let me put some description. Let me say Oracle Database Sharding demo here. And then the compartment is already pre-selected because it was selected in the previous marketplace screen. Now I click next. And this is where the user will get to configure Oracle Shard Database, right? So the first block of input is for general configuration. So the first thing a user would want to add is a customer, a sharded database name, right? And I'm going to put it as customer demo CD, right? And this is basically used as a prefix for all shard database resource display names. And the name must be unique within the subnet, right? Now, the sharding method is system managed, as I spoke earlier. And then the database software edition is enterprise extreme performance. And then the storage management software is LVM. And the license type here is license included. You could also switch to bring your own license, licenses. And then database version is 19C, right? With that, the shard configuration expects the user to input the shape, the number of primary shards, the shard database available storage size in GB per shard, right? So now we are setting that to 2, and then we're leaving it all to defaults, which is 2.1, and then 256 GB for per shard, right? Moving on, now comes the shard cataloging configuration. So it's pretty similar to shard configuration over here, except that there's going to be exactly one primary shard catalog. And you can choose the shape as well as the size of the catalog database. Now, the next user block is basically the application configuration. As I was saying, this is equivalent to the notion of replica sets. So if you want exactly one copy of a data, you want to set it as 1, which will be all primary based deployments. If you set it to 2, it'll be with standbys. And the replication strategy here is basically using data guard, right? Okay, and then this is going to ensure that all the shards and the catalog is protected by data guard, and so it's a one-to-one mapping from the primary databases. Okay? And then moving on with to the shard directory configuration, we have shape as well as number of shard directories which can be chosen. And then the user can simply click this single checkbox and then have a new network created. And this is recommended for the first very shard database which you deploy. And then later on, you could just uncheck this and then just choose from a previously created a regional subnet, right? And then you can choose your public key. So this is an RSA, a private key, public key, which you generated, and then you just pick it up for using this widget, right? So I click next, and then here you can review what you just input. And then let me go ahead and click create. So once I click create, it automatically starts the deploy job, and then you know, the rest of the deployment is done, right? So once it basically completes, then it will look something like this. So if you I earlier in the day today, I already deployed one. In the interest of time, I'll not wait for that particular job to complete. It might take a few minutes, about 15 odd minutes. So I want to be able to show you how it would look once the job, which I just deployed from our marketplace to deploy Shard database, looks like. So as you can see, the status shows that the deployment has succeeded in a previous deployment which I did for of a Shard database, and the number of shards and the shard actors, as well as the replication factor which we chose, is exactly the same as what we just went through. So as you can see, the connection string in the outputs, you can see the connection string. You can see you know, all the IPs and the subnet ID. Yeah, and then the user can look into the logs to see what's happened, right? And then it would show a successful deployment at the very end. So let me. So this is about deployment, right? So let me talk to you about management of this, right? So now, if you look at this particular stack deployment, as you can see, the first deployment was done via marketplace, and after that, the user can come into resource manager here and then go edit stack, right? So when they go edit stack, so you can actually change the number of primary shards as well as the number of shard actors. So you can either scale out or scale in both shards as well as shard actors. So I have done that already over here, and I'll just show that to you. So as you can see, initially the number of shards which were chosen were 2, and the replication factor was 2 as well, and the number of shard actors was 1. And if you look at the next stack, which has been edited and then applied this would basically have this is basically a scale-in operation. What I've done over here, with the number of shards from decreased from 2 to 1, and then the rest has been kept the same. The number of shard actors is 1, and the replication factor is the same. Right? So as you can see, this is also succeeded, and you can verify that it was indeed scaled in by looking at the number of IPs over here, right? So there were 2 here and before for each, and then now it's 1, right, for shards. And last but not the least, I want to discuss about destroying a shard. So as you can see over here, I have destroyed. I have done a destroy job. So the way you would do that is you go to a particular shard database stack and you'd go click destroy, right? And that will basically terminate all the shard database resources, shard actors, shard catalog, as well as shards. And then you would get a successful destroy message. And as you can see, there are absolutely no resources remaining anymore, right? So basically you know, in the demo I showed the initial creation and deployment of shard database, as well as management with scale in, scale out functionality, as well as complete cleanup of shard database if and when necessary, right? So now let me switch back to the slides in a second. Okay, so with that. That concludes the live demo, right? So Oracle Shard Database is actually right now live and publicly available on OCI Marketplace starting today for all customers to use. So please feel free to take it for a spin. And that's all I have for Oracle Sharding on OCI Marketplace. Param, if you want to share, take it away. Param?
Am I audible?
Yeah, now you are. Take it away, man.
Thank you. So thanks, Bharat. So we'll be here covering Oracle Sharding on OKE. And this solution can be deployed on OCI as well as on premise. And here, I specifically talk about how to deploy it on OCI, whether it's a Docker container or whether it is OKE-based solution. So we'll go with the Oracle Sharding on Docker container. We have already released this solution on Oracle Sharding GitHub repo, and it's available there. So what you need to do, you need to build the images or pull the images from OCR. And once you pull it from there, you need to build the container, JSON containers, catalog containers, and the shard containers. And it will automatically provision the environment inside the container. And once the environment is provisioned, it basically publish the message on the Docker console that yes, it's been completed, and then you connect to your application. Once you connect to your application, you can test it, and it's as is the way you connect to your any other sharding database. So using IPs and everything, it's same. That you can use GSM and everything for the connection. Similar thing we can do with Oracle Sharding on Kubernetes. You need to clone the Sharding GitHub repo, and you create a cluster in OCI. For that, we have provided a number of Ansible playbooks. You consume the Ansible playbooks and pass the YAML file to it. And once the YAML file is ready, Ansible playbooks basically consume that and provision the OKE cluster. And we have a Hellman chart to set up the shards, catalog, and GSM. And you can add and delete based on your requirement. And once your cluster is up and running, it's all yours. Addition, deletion can be done using Hellman chart. So I'll quickly switch to a demo where we can see that how it looks like. It's a very small demo, but it provides the feel of this. So this is our YAML file for the OK cluster. You can see that you need to clone the repo and then populate this file. It has all the details like what IP addresses you want to specify, subnet DIR, and your VCN details, and what Oracle Linux image you need. Everything you need to specify over here. Your public key, your SSH key, whatever you are trying to connect to the instance, and then you go to the values.yaml. Once your OK cluster is up and running, then you specify your all the parameters related to GSM and shard and catalog, and you need to specify the ports, the mount points, and the images. Here you can see that we have specified all the mount points and everything. Specify everything over there, and number of shards you need to specify, catalog, and everything. Once that part is done, then what we need to do, we need to provision the cluster. But in this case, we have already created the cluster just to save the time. And you can see that we have two node pools, GSM node pool and Oracle Shard node pool, and the cluster is OK cluster. That's the way it looks like. And this is done by the Ansible playbooks. Now, once the cluster is up and running and Hellman chart has provisioned that, you switch to the console and export the kubeconfig path, and you can see the cluster up and running. And you can see the number of services are there. There are a number of headless as well as other services. You connect to GSM, and that's what it is. I think, thank you very much on this side. Hey, Shailesh, I think you can take it over.
Great. Yeah, thank you so much, Bharat and Param, for those demos. So I think, I hope the key point there being that we can configure sharding on top of database cloud services, and we have two options. One is we can use the database cloud service as the starting point and shard it. The other demo which Param just showed, which is basically using the OKE, which is Kubernetes and Docker images, using that and configuring databases in Oracle Cloud and sharding on top of it. So these are some very exciting options which are available. There were a bunch of questions on the chat. So one of the questions was around, maybe I can address that here, was around if multi-region. So the automation which Bharat showed is about a single region right now, but we can configure multi-region as well. It's just a matter of time. We just need to do a little more work for automation, but there is a customer need to configure multi-region. The same thing which you saw within a region can easily be configured across other regions. So whether it's in a specific geography or across the continent, we can support that today with a little bit of additional scripting. The automation, we are working on that. So feel free to reach out to us for that. There was a question around specific around do we need anything more on top of DBCS? If somebody has a DBCS subscription, then there is nothing more needed. That is all. Sharding is included as a part of that deployment. Are there any other questions? Tammy, we can open the line if there are questions.
Yeah, there's a couple in Q&A. If you want to take a look at those.
Yeah.
Sharding on top of Kubernetes is not redundant conceptually.
Yeah. So
I'm
control the shards. Okay, thank you.
Lorin, I'm replying to that, and it's not. Actually, we are using OKE pods for the compute, and the high availability of the Kubernetes, we are utilizing it for the sharding perspective, but the database connections are still addressed by the shards only.
So in a nutshell, this is all the solutions we looked at today are highly available, and they ensure that there is no data loss in case of any kind of outage, right? So where I think there is a question around sharding on top of is not redundant. That is not the case. What we have done is we use persistent storage for storing data files, and we are using containers to run the database server part of it. And if some of the containers go down, we have a couple of options for failover. One, Kubernetes itself tries to restart, and as we talked about earlier, that we have a data guard configuration feasible as well, so that there is no data loss if at all an instance goes down. And all the routing, etc., which is done using GSM, which you can think of as another component for connect time and runtime and database connection, routing and load balancing. That takes care of ensuring that the application gets connected to the right instance if there is a failover. So the drivers we talked about also the different drivers like OCI and JDBC, etc. They are all sharding aware, and they connect through this GSM component, GDS and GSM component. So they also have things like application continuity, etc., which is built into our driver that has been extended to work with sharding. So in case of any failover, blip or brownout, right, I touched upon earlier, if that happens, the applications can seamlessly get connected to the new instance. So there's no single point of failure in the entire architecture which we showcased today.
There's another question. I appreciate Lorenzo asking all these questions. Okay, about data guard and OKE, it's being all done for you.
Yeah, so Shailesh just wanted to learn that is under testing, and we'll publish it soon once we are done with our evaluation. Yes, it will be available.
Awesome. And you answered the Docker question. I saw it was gone. So.
Yeah.
Okay. There's another question. Can a single table be partitioned across multiple shards? If yes, then if any shard goes down and subsequently, if user queries for the full table data, then what will happen?
Yes. So yes, of course, a single table can be partitioned across multiple shards. That's the example I was using. Some of our production customers who have been using sharding for a while, they have really large databases talking in terms of hundreds of terabytes, and they have these tables are big they themselves. So that's the reason why you would partition. So we not just single table, but a table family, as I talked earlier, which you can think of as a set of related tables which you want to partition across all the shards. So yes, you can do that. And if a shard goes down, and if you run a query, so when we run a query, I think there are 2 points to keep in mind. One is that our goal is to, when our goal is to route your query directly to the node where the data is residing. And as I touched upon earlier, we typically use something like a sharding key to identify that. So for example, customer ID is say a sharding key, and we know our query is for customer ID 1, then that query gets routed to shard number 1 automatically, right? Our drivers do that for you. And then all of the data for that customer resides on that shard. So the joins and whatever else we run gets satisfied locally on the shard. So that's one example of the query. Now, if you want to run a query which spans all shards, for example, select count star from customer, where I want to see the total number of customers across the globe. Now, of course, that query, as I said before, we have multi-shard query coordinator, just like Hadoop MapReduce or many other products out there in the market, where we take the query, we optimize it, and we push the query in parallel on all the shards, and each shard run that query on subset of data they have, and the results are result back to the application. Now, in that scenario, if one of the shard is down, we have two options which customers can define. One is they can say that basically they can say whether partial results are acceptable or not. And what that means is that you're saying that if shard number 2 is down, which means customer 101 to 200, those 100 customers, will not come back in my query if I were to accept partial results, right? So you can turn that knob on and say, I'm fine with partial results, in which case, if there is a specific shard which is down for whatever reason, is being filled over or blip, then we can return the partial results if you choose to do so. By default, we believe in data consistency, so we will fail that query if one of the shards are down during the query execution, so we don't want to give wrong results. So that's the default behavior. In 20C, we have added an additional capability that if a shard goes down while a query is being executed, we wait for, and if there is a failover being triggered, as we all know, we automate the failover of a shard. So we wait for that failover to complete. And then we will resume the query on the new primary, which was, let's say, an earlier standby, and finish the query and then return the results. So the results may be, if you say that partial results are not acceptable, which means I want all or nothing, and there is a failure which happened, then there is a shard which is being failed over. We will wait for that failover to finish and resume the query and then return the result back, in which case the results may be slightly delayed, but they will still be accurate, right? So that's how it works.
Fantastic. Shailesh, do we have any external customer references by any chance?
Yeah, so we have many customers already using it in production. I think China Telecom was one of the early adopters. They have been using from 12.2 onwards. Sharding has been around since 12.2. Epsilon is another reference customer. Citibank. So these are the customers who have publicly, co-presented with us at event, and their case studies on our website. We have many other big customers in telecom industry, in banks, in credit card, financials, marketing, so on and so forth, who are not currently a public reference, but they've been using the product for quite some time, and some of them have recently gone live. So we are working on newer case studies, but we do have few of the public reference case studies out there as well.
Are those case studies found on the Sharding product page on o.com? Is that where you find
Yes.
it, or under customer references? Okay.
Yes.
Fantastic. All right. I know Bharath is answering a question. Bharath, you want to answer this question live? Is there something?
Sure.
Okay,
Sure. So the question is there something called as a master among the shards, which is single point of failure for entire Oracle sharding? The answer is no. All the shards are equivalent. All the data is distributed across all the shards. And the shard catalog, which maintains the metadata and is responsible for shard querying for fanning out and fanning in, is also protected with DataGuard. So there's no single point of failure in the entire Oracle sharding architecture. Yeah.
Yeah, and it's, as I said before, it's a shared nothing architecture, so it's not a master slave of any sort. There is no master, there is no slave. As Bharat alluded, everything is equal and everything is highly available.
That's excellent. Okay, there's some really good questions coming in. Does anybody have any last minute questions? You guys have been doing a great job at asking questions. Shailesh, Bharath, or Param, any last minute thoughts or anything to leave with our audience?
I'll just say all of the content we showed is already live in production. So if you have an Oracle Cloud account and you want to kick the tires, feel free to do so. We have put all the links on the slides. Yes, the slides will be shared. There was a question on that.
Yep.
And all the links are there to our documentation, to our product site, to the URLs, etc., the marketplace offering, GitHub. So all of those links are there in the slides. Please go ahead and give it a try. And if you have any other questions, feel free to reach out to us. And if there are any other combinations, any other additional requirements which you have, we'll be happy to listen from you and put it on our roadmap. So thank you so much for your time, and back to you, Tammy.
Thank you so much. One last question. Is there any split brain in sharding? Is that a quick answer, a question?
No.
Okay.
There's, as I said, there's no notion of master and slave here. The data is partitioned, and so there is no like a chance of having any kind of split brain scenario.
Fantastic. Thank you guys very much. This was very informative, great information, and thank for everybody for joining today. Great questions. Look for us in July on another session of our Database Cloud Service Office Hours. We'd love to hear from you. If there's any topic that you would like to hear from our database team or our Database Cloud Services, please drop me a line at tammy.bednar@oracle.com. Love to hear from you. Would love to hear what your thoughts are and what we can give you as well. All the recordings can be found at AskTOM.oracle.com. If you go to our office hours, you'll see any previous sessions and recordings there. And if you go to use the link that you used today to join today, that will take you directly to this office hours, and you'll see the previous sessions. Give us a day or two to get this one posted, and you'll be able to download the PowerPoint and also review the replay. So with that, I'd like to thank you guys very much for attending. Please stay safe out there, and we'll see you next month on Database Cloud Service Office Hours. Bye now.
Bye, guys. Thanks.